Let's now prove that the square root of 7 is irrational. This will be again a proof by contradiction. So let's suppose that it's rational. If it's rational, that means that I can write it as a fraction. So suppose that square root of 7, it can be written as m over n. And let's suppose that this is in lowest terms, so that the greatest common divisor of m and n is equal to 1. Then, if I clear out the denominator, that means that n times the square root of 7 is equal to m. Or if I square both sides, that means 7n squared is equal to m squared. So 7 times something is equal to m squared. That means that 7 is a factor of m squared. And from one of our theorems in class, 7 is a prime number. And so if 7 divides m times m, that means 7 divides m, or 7 divides m. Well, that either way, 7 divides m. So 7 divides m, using the theorem in class that if a prime number divides a times b, then the prime divides a, or the prime divides b, possibly both. So 7 divides m. So let's write m is equal to 7 times some other number k. Okay, so let's plug that into this. So 7n squared is equal to 7k squared, which is 49 times k squared. Okay, so 7n squared equals 49k squared. I can cancel 7 on both sides, so that n squared is equal to 7 times k squared. And m and n are integers, k is also an integer, and so 7 is going to divide n squared. And just like before, if 7 divides n squared, then 7 divides n. And so therefore, if we take a look at this, 7 divides m and 7 divides n. So note that 7 is a common factor of both m and n, and so the greatest common divisor of m and n has to be at least equal to 7, because 7 divides n and also 7 divides m. That's a contradiction because we assumed that m and n were relatively prime, so that the GCD was equal to 1. So that's a contradiction. And therefore, square root of 7 is not rational. And that's the end of the proof.